Hello everybody, it's Mrs. Pound and I am back with chapter 4.3 on types of machines. So our first section, section 431, is going to be about simple machines and inclined planes. So our objectives for today's video will be to determine the effect of an inclined plane on work and force and to calculate mechanical advantage and efficiency. So there are going to be 6 simple machines that we are going to talk about in this chapter. They are the inclined plane, the lever, the pulley, the screw, the wedge, and the wheel and axle. So an inclined plane is a simple machine that has a slanted surface, like in the background. So a ramp is an inclined plane. Can you think of other places that you see inclined planes? The formula for an inclined plane is mechanical advantage equals length divided by height, or MA equals L divided by H. So let's take a look at a problem that involves this formula. So if a 10-meter ramp that has a height of 2 meters was replaced by a 15-meter ramp of the same height, how would that change the mechanical advantage? So we start with our formula, MA equals L divided by H. And then we substitute in the first set of numbers. 10 meters divided by 2 meters equals 5. Now remember, for mechanical advantage problems, there are no units because the meters cancel out. Now if we increase that length to 15, then we have 15 meters divided by 2 meters equals 7.5. So actually, by lengthening the slope, lengthening the ramp, we increase the ideal mechanical advantage of the inclined plane. Now, one thing that we are doing, remember, we're doing the same amount of work, ideally. But what we have done is we're using less force over a longer distance. So we are making the work easier with an inclined plane by using less force over a longer distance. Another type of problem we might see is if an inclined plane has an IMA of 5, an output force of 150 newtons, and an input force of 300 newtons, what is the AMA? So efficiency, remember, is equal to work output divided by work input times 100%. So when we plug in the numbers, 150 divided by 300 and multiply by that by 100, we get 50%. So it's only 50% efficient. Now we can find the actual mechanical advantage. To do this, we multiply efficiency times the ideal mechanical advantage. So 50% in what I call cents form, or dollar form, instead of cents form, times 5 equals 2.5. And remember that mechanical advantage is lower, actual, because of friction. That takes into an account friction. Now, if you are listening to this video, go ahead and I will know that you are listening to this video. I want you, next to this answer of 2.5, to draw a triangle representing a ramp. So it has to be a right triangle next to this answer to represent a ramp. Now, the IMA is always greater than the AMA because it does not include friction. Now, engineers work to improve the efficiency of the machines they design. However, they do not strive for 100% efficiency because, and we have talked about in class how no machine is 100% efficient. In fact, that longer ramp that reduces the amount of work will actually be less efficient, but we might want to make a ramp longer to just make the work easier. Even though we end up doing more work overall, if we can make it easier, it might be worthwhile. For example, if an individual is in a wheelchair, a longer ramp might be beneficial to them because they can actually roll it up the ramp, where a shorter ramp, they would just roll back down, so it wouldn't be of use to them. So the reason engineers do this is because a 100% efficient machine means no friction exists, kind of like this snowy, icy road. If this is going uphill, so it's very much like a ramp. And just think, when you're on an icy ramp, you slip and fall. It's not doing you any good. You need the friction to be able to, in a sense, stick to the ramp and go up it. So friction is necessary to control motion. If you get on this road, you could be totally out of control. If you're going up an icy ramp, you will be out of control. And machines would be useless without friction. Without friction, you wouldn't be able to go up a ramp because it would be too slippery. So it would be totally useless. So our objectives today were to determine the effect of an inclined plane on work and force, calculate mechanical advantage and efficiency. So don't forget your 5 questions, and will be back with more about machines.